January 17, 2012, 2:30 p.m. Camera says it's 4:21 p.m. I don't know why that is, but we got some mighty strange things going on here. We got a machine that distorts time. So we asked the question, can three phases of 120-degree AC be combined in series to yield the sum of their input voltages? Now we make a comparison of how if we had three 1-volt signals and we did a three-phase rectification and obtained direct current voltage, if each of them signals were 1 volt, the most that we could get out would be 2.8 volts, according to that analysis there. And the way that we're distorting time, we're going to demonstrate this right now. We're going to look at our stator voltages. We've got 5.9, 5.8 volts on phase 1. We have an energized field running the alternator to the process. We have 6.7 volts on phase 2. We have a cyclic activity that we will demonstrate on scope. And on phase 3, we have 5.6 volts. The reason that we know that we have a time distortion process here is because of the law of cosines, and on 1-3 the voltage differences between phases 1 and 3 is only 15 volts, whereas on the other differences of the resonant rises of voltage, we have 80-some volts, and our resonant rises of voltage themselves are 50.3, 48.1, 48.4. In order for the vectors to satisfy the equation, we take the flat piece of paper information and fold it into a cone so the distances between 1 and 3 can become smaller. In order to do this, the vectors must become three-dimensional vectors. We still have some problems with phase 3 and why it's doing what it's doing, but today we're just going to look at the evidence. As noted, we'll start out here. We have 6.7 volts on phase 2. We have, on the checker coding scheme, we have one secondary under phase 2. Phase 2 is blue. We have a scoping of that voltage. And we have a meter on that voltage. And these spirals will pick up the same voltage as the phase that it's facing. So on our sensor we have that spiral facing phase 2, and we have 6.9 volts being created from that 6.7 volts. And then we're going to add these in sequence. Next we're going to be adding 5.8 volts. And 6.7 obviously would be 11, 12.5, 12.5. We're going to have the second sensor over here on top of phase 1, and we're going to move the voltage here. Make sure we can see both the scope form and the voltage meter. Now we have 13 volts, 13.11 volts. Scoping's gone up. And we got 5.8 and 6.7, which should be 12.5. Now we're going to go to the third final sequence around the circle. Now we're going to put an inductor over phase 3. And that's going to be the sum in series of all them voltages. We'll be able to finish up here. 13 volts. We now have a voltage meter reading 18 point volts, and the scoping may not show that, but we're going to show why in a second. We've got a voltage meter reading a fluctuating 18.3 volts. We've got meterings over here showing the sum of the input voltages. We got 5.8, 6.7, and 5.5. There's the calculation. I'm trying to show here. We just showed what the stator inputs voltages were. We got 18.2 volts, the summation of them voltages. And on the calculator, we have 18 volts. That calculator's not going to stay there. Hopefully you can see that in the screen. So we have shown that we can sum the voltages that were initially out of time. We can put them in time with this process and add them sequentially. This implies that for 3-phase we can now using this process, obtain 50% more power. Now we're going to show something else. Notice that the waveform appears to be moving up and down. It is in fact moving up and down, and it does in fact have a cyclic activity, and that's due to the nature of the machine. It produces two different frequencies. One frequency is slightly higher than the other. Now I'm going to turn this brain sweep down and show this. See, over that time period, we went from 2 milliseconds, which is the approximate cycle time, to 10 milliseconds. So this shows here that in 50 milliseconds, or approximately 25 cycles, the induced EMF from the air that adds to the component has circled around one complete revolution in 25 cycles. On the next video, we will show some particulars of this and how we can stop this from happening by loading. Thank you.